We are fortunate enough to work at the RSPB Forest and Ard Reserve, where peatland restoration has been taking place since the mid-1990s at landscape scale. In this area, large areas of blanket bog were planted with conifers in the late 1970s and 80s. If you have a look on the roof of the car, you can see in green where such a forested areas were.
Came up the Strath, got the track round this little hill, and we're now here.
Here.
This is where all the forested stuff has been felled.
So this map's quite old, isn't it? It still shows all the forestry. Yeah. What are you up to do today?
So we'll visit the flux tower. We'll go and download the data and do the maintenance on that. Which should be all quite standard. Talk through it, and then head out to Tyler Hill as well and do the same there, I think.
Okay.
And then tomorrow we can go to Crosslocks and to Dyke.
Okay. And we're off to do two different things. So one is to get vegetation quadrats at 10 by 10 metre scale, so we can correlate them with satellite data. So a satellite would look at this area just like we are just now on this map, and they would just see 10 metre squared tiny little pixels within each of these areas. So it's to get some ground truthing data for that model. And the second job for today is to put in those things for water level loggers and soil moisture loggers. And that number is 10497. Gillian and I are here because we are trying to find out whether peatland restoration works. And what we're trying to do is assess that at three different scales. So what Paul behind us is doing is setting up experiments to check how moist the surface is, to see whether restoration recreates a wet surface environment. And we're going to tie that in with data from satellites, isn't it? And that's partly what your interest is, isn't it? To see if we can link the data together.
Yeah, to see whether the satellite data can actually provide in some way a measure of what we're observing on the ground, but in a much quicker, larger kind of format.
Yeah, so what sort of sizes are the images that we would be seeing from a satellite here? How big a piece of ground?
Well, the ones I'm working with at the moment are 5.5 kilometres by 5.5, so you're pretty close on 30 square kilometres.
Wow, that's amazing. And each individual pixel, each bit of ground that you see, how?
That varies. Each pixel is about, on the older photographs, about half a metre, but it can go down to a couple of centimetres if we use these unmanned aerial vehicles, or drones as they're called.
Wow, that's amazing. So you would be able to see little patches of sphagnum like this on the
higher detail, yeah, no, definitely.
If you can get all this amazing data from the satellites, that only really tells you a little bit about the colour of the vegetation or what stage of the growth it might be in. How do you link that to greenhouse gas emissions?
Well, you'd have to have some kit on the ground, so to speak, your flux towers and the measuring instruments on them to actually provide you the additional information, because it's no way, well, the satellites we're using could provide you that kind of detail,
not straight away.
Carbon dioxide emissions and so on. So, but by having equipment on the ground that's continuously monitoring and recording that data, we can put the two together and actually look at correlations. So
one of the reasons we have these instruments in locations like this for a long period of time is to understand how resilient restoration practices are in restoring peatland to its maximum functional level. So this year, for example, we've had 2 months of very little rainfall, extremely low rainfall. And as you can see, some of the sphagnum here has dried out. This white sphagnum is photosynthesizing less, so it's taking up a lot less carbon dioxide from the air than this green material would do. So already, if you imagine this over the landscape, if you have a lot of desiccated sphagnum, at this point in time, it's not functioning at its optimal level.